Have you ever wondered why space is silent? Let's embark on a journey through the cosmos and explore this intriguing question. You see, sound as we know it is a type of energy that moves through the world in waves, much like ripples spreading across a pond. These sound waves, they need a medium to travel through, be it air, water, or solid objects. When you hear the soft rustling of leaves or the melodious chirping of birds, it's because these sound waves are traveling through the air, reaching your ears and being interpreted by your brain. But what happens when there's no air or any solid matter? Well, that's where space comes in. Space is a vacuum, devoid of the very medium sound needs to propagate. That's why when you're out there amongst the stars, it's eerily quiet. So in essence, space is silent because there's no medium for sound to travel. To understand the silence of space, we first need to understand what sound is and how it travels. So let's dive into the world of sound waves and their propagation. Sound, in its essence, is a type of energy made by vibrations. When an object vibrates, it causes movement in the surrounding air particles. These particles bump into the particles close to them, which in turn bump into the particles next to them, and so on, creating a chain reaction of a wave of vibrations. We perceive this wave of vibrations as sound. Now, these sound waves are what we call longitudinal waves. This means that the particles in these waves vibrate back and forth along the path that the wave travels. You picture it like a slinky spring. When you push one end, the coils compress together in a tight formation, then they spread out again. That compression and spreading out is what happens in a sound wave. But here's the catch. For sound waves to travel, there needs to be a medium, something for the sound to move through. On Earth, that medium can be air, water, or even solid objects. Sound travels through all of these mediums. In fact, sound travels faster in water than in air, and even faster in solid objects. That's why if you're underwater, sounds can seem louder, and if you put your ear to a railway track, you can hear the train coming long before you can hear it in the air. However, when we get to space, the rules change. Space is a vacuum, meaning it's almost entirely empty of matter, including air particles. So, without a medium to travel through, sound waves can't propagate. In space, no one can hear you scream, not because of some alien monster, but because there's no air to carry your voice to their ears. So there you have it. Without a medium to travel through, sound waves can't propagate, leading to the silence we observe in space. Space is not like our earthly environment. Why it's a vacuum? This statement might trigger some questions. What exactly is a vacuum? How does it differ from our earthly environment? Why does it matter when we're talking about the silence of space? A vacuum, in the simplest terms, is a space devoid of matter. Picture a room where you've sucked out all the air, all the dust particles, all the tiny microbes floating around, everything. That's a vacuum. It's a concept that may be a little hard to grasp because here on Earth, we're never in a place that's completely empty. There's always air around us, even if we can't see it, but space is different. It's not completely empty, but compared to the air-filled environment we're used to, it might as well be. There's no air in space, no substantial particles. It's this absence of particles that plays a crucial role in why space is silent. You see, sound as we know it needs a medium to travel through. When you speak, your vocal cords vibrate, pushing and pulling air molecules around them. These molecules then bump into the ones next to them and so on, creating a chain reaction. This reaction is what we perceive as sound. But this chain reaction needs a continuous chain of particles to keep going. In space, there are so few particles that this chain reaction can't occur. If an astronaut were to scream in space, there'd be no air to vibrate, no chain reaction of molecules. The sound wouldn't propagate, wouldn't reach another astronaut even a few feet away. That's the essence of a vacuum. It's not just emptiness. It's an environment where our usual rules of sound don't apply. Because there's no medium for sound to travel through, space is effectively silent. So the next time you look up at the night sky, remember this: those stars, those galaxies, they're all in a place where sound as we know it doesn't exist. The vacuum of space is the key reason behind its silence. While space is largely silent, there are some exceptions to this rule. Now, I know what you're thinking. How can there be sound in space when we've just established that it's a vacuum and sound cannot travel without a medium? The answer lies in our understanding of what sound actually is. Typically, we think of sound as something we can hear with our ears, but in the vast expanse of the cosmos, sound takes on a slightly different meaning. Consider for a moment, the Sun, this colossal star, is constantly emitting a stream of charged particles known as the solar wind. Now, these particles don't produce sound in the way that, say, a strumming guitar does, but they do create electromagnetic vibrations. These vibrations can travel through the vacuum of space, and with the right equipment, we can detect them. Then there are phenomena like pulsars. Pulsars are highly magnetized, rapidly spinning neutron stars that emit beams of electromagnetic radiation. This radiation can also be picked up by special instruments and converted into a form that we can. Even phenomena like the northern and southern lights, also known as the aurora borealis and aurora australis respectively, are caused by charged particles from the Sun interacting with the Earth's magnetic field. These interactions create electromagnetic vibrations, which again can be picked up and converted into sound. But here's the kicker. While we can convert these electromagnetic vibrations into sound we can hear, it's important to remember that they are not sound in the traditional sense. They don't travel as waves through a medium like air or instead, they are forms of electromagnetic energy that can traverse the vacuum of space. So while we can listen to the sun or a pulsar, we're not actually hearing them in the way we would hear a bird sing or a car engine roar. These exceptions, however, are not sound as we know it, but rather forms of electromagnetic vibration.